Good morning or good afternoon, everyone. It's different location, different time. My topic will be about bioaccumulation of heavy metals in micro and red hybrid tilapia collected from Tijal and Dhaka in Yemen, Malaysia. First of all, my name is Ahmad. I am from University College at Malaysia. Very happy to be with you today. Why we are talking about biomonitoring? Industrial rapid growth as well as agricultural and mining activities has led to significant impact on environment. So waste coming from land, from factories, from whatever, goes finally to the seas or to the rivers, and this comes again to our food. So it's better to check whether it is healthy or not before we consume. Another thing is fast development in aquacultural fish industry, mainly tilapia. Shrimp farming expected to be 50-50 by 2030. This is in East Far East Asia. Malaysia is one of this country, and it's expected to get 50 of aquacultural industry. Biomonitoring is a good tool to know the source of contamination, mainly in the food we consume. Especially if we know that Malaysian consumption is higher than other people in the world. Per capita in Malaysia, if you want to know how much the consumption, you find that every year 61.1 kilogram for everyone in Malaysia, which is very high compared to other countries. You see this one supply demand in Malaysia, and this is annually very significant increase. This is the Asian net surplus of fish values. This is in Malaysia, around 58.1. This is a long time ago, but now it's increased to 61. And protein coming from fish is 16.8 compared to the total from other animals like cows, sheep, which is 43. So this represents about 50% protein coming from human consumption in Malaysia coming from fishery resources, and which is also higher compared to the neighboring countries, like Cambodia, Indonesia, Laos, Myanmar, Thailand, and Vietnam. Here, this is the expectation, production and consumption. So you see here, by this 2014, it was only 36. This is from aquacultural activities. This is production. This is consumption. But 2030, it's expected to reach around 50%, 48. And by 2050, will be 51 and 49 from obesity. So you see the production and consumption in Asian countries is very high. Here, this is the marine capture production, major production countries in hunted territories. This is around 20 countries or 25 major producers. You see Malaysia here is considered to be, maybe number 10 in the world. And those countries represent around 80% of the international. This is here from aquacultural activities. This is from the open sea, different way of capturing fish. So in this work, my objective is to evaluate heavy metal situation in Bakka River and Tijal through biomonitoring of zinc, copper, nickel, and lead. Bakka is represent aquacultural, Tijal open culture. Compare the results obtained with FAO. This is Malaysian Food Agency, WHO, and so on. And then reason for the contamination if exists. Here we start with the mackerel estimation of consumption in Malaysia around 200,000 tons. This is 2018, and 2022 is not a big difference between 2018 and now. And here, if we talk about tilapia, you see this is very significant increase in consumption of tilapia. This aquaculture is very good because easy to capture and easy also to farm, not difficult. So 53% of this consumption coming from the red hybrid tilapia in Malaysia. This is why we farm, in the farming aquacultural, red compared to black is more. There are many reasons. One is that easy to, easy to grow and doesn't need too much care. And also the growth is also very fast. And also the production in terms of protein content is very high. This is tilapia in metric ton, different years, 20,020. This is in the fish water about, this is a million ton, 725, 119. And this is compared with other also marine species. And this is the development strategy that by 2030, supposed to get 50-50 from urban temperature, you see, and also from aquacultural activities. The sampling area, I took my samples from two different areas. You know, this is Malaysia, this is the West Malaysia, here is Malaysia, Sabah, Sarawak, here West Malaysia, here Terengganu, this is the state we have. And we take from two different areas, Bakka River and also Kujaj area. Not very far, but this Bakka represents industrial area, and this one represents somehow aquacultural activities. And we take also beside the sample itself, fishes samples, we take also sampling of sediments to see the effect of samples on the tissues and bones of the fishes. Methodology sampling and then washing, drying, crushing, and then digestion by acids, and then go for dilution, and then analysis. So for analysis, we use moisture content in the bones and also in the tissue or in the fish. And then after that, we measure heavy metal by atomic absorption spectrophotometers. As you see here results, this is heavy metals in tilapia, tissues and bones. In tissues is less than 1 somehow, and it reaches the maximum concentration of heavy metal is lead. It reaches to 228. This is part per million, which is very high somehow, but others somehow normal except zinc, which show in the bones high concentration. We go to mackerel in Kunaman, Kijal Kunaman. We found also lead is high in bones and tissue also, but less than 200. Others also zinc somehow bigger in the bones or higher in the bones. Other copper and nickel somehow between 28 and 17 parts per million. In the sediments, we found also here in the soil, Bijal and soil Pakka, we find in the soil Pakka is much more higher. And we say that because of the communication and the before questions. concepts.